we have the integral of e to the square root of x evaluated from 0 to 1. Now, the first thing that we would like to do for this one is let u equal the square root of x, and the derivative of u in this case would be 1/2 x to the negative 1/2, which can be rewritten as 1 over 2 square root of u dx. And now in our integrand, we're just looking to get dx alone, and over here we have all this stuff times dx. So to remedy that, we just need to multiply du by 2 square root of x, because then we'll have 2 square root x du equals dx, and dx is now alone, just like we need it to be. The next problem is that we have x and u in the same side, and we need to remedy that by replacing square root of x here with u. So this is really just 2u du equals dx. And now that we've got our dx and our u sub figured out, we can go ahead and plug this all back into the integral. So we've got the integral of, we've got a 2 here, so we'll poke that out front, and then we have u coming from here as well, that goes inside of the integral, e raised to the u du. And that's because u, again, is actually the square root of x, and that comes from here, so e to the u is e to the square root of x. The next problem is we have our bounds to deal with. Initially, what we had is we had when x equaled 0 and 1, those were our bounds, and now we're dealing with u. So now that we have u, we can have when x is 0, u still equals 0 because the square root of 0 is 0, and conveniently, when x is also 1, u equals 1 because the square root of 1 is still 1. So what we can do is pop 0 and 1 back here. That was fairly fortunate that it worked out so cleanly. And now we just have an integration by parts to perform. What we've got is a clear product here with no easy way to u sub that to solve it. So what we can start with is letting w equal u, and the derivative of w equals the derivative of u, and then we'll let dv equal e to the u, and then integrate that to get v, which is also e to the u. We'll go across the top and then down over, and we'll end up with 2 times u e to the u minus the integral of e to the u du. And this integral is evaluated from 0 to 1, and this is also evaluated from 0 to 1. Now the integral of e to the u is conveniently just e to the u, and we will evaluate that from 0 to 1. So we can just rewrite this all as 2 times u e to the u minus e to the u, all of this evaluated from 0 to 1. And now we can just go ahead and plug these values in. So what we've got is 2 times 1 times e to the 1 minus e to the 1 minus, in parentheses now, we've got a 0, so 0 times e to the 0. E to the 0 is 1, but it's multiplied by 0, so it's nothing. So it'd be 0 minus e to the 0 once more is just 1. And so what we've really got is 2 times e minus 0 minus 1. 0 minus 1 is negative 1. Minus negative 1 is just positive 1. E minus e is, of course, 0. So what we actually have is 2 times 1, which equals 2. And that is the solution to the definite integral of e to the square root of x from 0 to 1. If you have any questions, or if you have any other calculus problems you want me to work through, leave them in the comments below. Otherwise, I hope that you found this helpful.